Well, when you see the string on there, I think you guys know we should probably go to a force diagram. What are all the forces acting on the block? We have force of gravity. I'm going to put 2 on here. We have the tension of that string. And then we also have a force of buoyancy. Since it's not accelerating, we know that the tension plus the force buoyancy minus the force gravity equals 0. I thought we were supposed to find the tension, so let's turn that into tension equals force gravity minus force buoyancy. So I'm going to bring that back over here and see what we can do with that. The tension, force of gravity, this is where it kind of went off the rails the other day in class because I wasn't very clear, and I'm going to apologize again. Weight equals mass times gravity. We don't know the mass, but we have a density, so we can go a different way and go density equals mass over volume. I know, oh my God, that's horrible. I know the density and the volume, so I can turn this into mass equals density times volume. So I can really get the mass this way. So mass times gravity, I'm going to substitute what mass is, density times volume, but I still have to times it by gravity. So that's the density of, what is this, aluminum, the volume of aluminum, and then don't I have to subtract off force of buoyancy? And force of buoyancy looks a lot like that too. We have an equation for that. The density of the fluid, volume of the fluid times gravity. So now it's just a substitution game. The density of aluminum is 2,700 kilograms times meters cubed. The volume of that, now that's, we might have to go over and do a little side problem again. 100 centimeters cubed is the same thing as 100 milliliters. And if we put that in here, didn't we have to go 1 times 10 to the negative? Alright, totally got interrupted on that, and it's like an hour and a half later, so I think I know where we left off. Not like that. Alright, let's see, this must be milliliters here in 1 cubic meter. Yes, there's a coffee going, a coffee pot, and it's going to make a bizarre, I'll wait. Alright, coffee's made. So the volume of aluminum, I believe, let's put this in parentheses since we're going to multiply it, is 100 times 10 to the negative 6th meters cubed. You can see I'm going to run out of room here. Alright, I'll come down here. So I'm still trying to find tension. I just moved everything down so I can get some room here. So that's moved down here. I'm at gravity. I believe that's 9.8 meters per second squared. They should all be. Now I have to subtract off the density of the fluid, which I think they told us was 790 kg over m cubed. And the volume of the fluid, which would be the volume displaced, right? Which should be the same as the volume of that cube. Volume displaced would be the volume of the cube. Meters cubed. And finally, gravity again. Meters per second squared. So remember, you got to do this number first, then that number. So this blue number, I think I came up with 2.646 newtons. I have to subtract away 0.7742 newtons, and that should give me an answer of 1.87 newtons. Remember, force is in newtons and tension is in newtons, so hopefully that works. Alright, sorry for the janky video, but hey, I'm at school, I get interrupted. Bye-bye.